Yeah, so we continue. Today we only have 1 hour, so we continue. So last lecture we stopped at this equation, which is I equal to integration R square dm, and the most important equation is this one. I, which is the moment of inertia for rigid body, equal to Ig plus md square. All right. So moment of inertia, because we're looking at particle, we look at rigid body, we have two components. One is the center of mass or center of gravity, that we'll give dot and then we give a capital G there lah. Okay. And another part is more on the mass effect, total mass effect, the whole body total mass effect. The term Ig here is center of gravity effect, the dot, the center or the focus of the G point. But the back one, md square, is the total body mass effect. Yeah. So this md square actually referring to this d. You always need to look at the question O. You're given the origin position or reference position. This one d. Okay. So for example, this diagram, your d is this one. It's from A to G. Yeah, is to A to G is your d. Then previously we stopped at this tutorial question. Okay, and I have updated the appendix. So the previous appendix in the island actually also got error. So I already updated the appendix in the island, and I'll give you the copy, update copy this today lah. Okay, so we already proved how to get Izz half mr square. Already proved how to do that. Okay, and back to this equation. Ig, this one, Ig always refer to the appendix. Always refer to this appendix. So and then you imagine how you combine the shape, the body lah. Okay. So previously we covered this one, and we know that from this photo you have the O and a G. So again, you only need Ig plus md square. Ig refer to the appendix. So you look at the shape and then you refer to the shape, and then the axis. Important is the axis. So for example, the ring, this one, the ring, and not this one, not thin ring, but it's this plate. So you see, you're actually looking at the center of the ring. You focus through the center hole there. So you're looking at the Z axis here, right? So when you're looking at the Z and the G position is at the center, so you go here and find lah. So you have Ixx, Izz. So you're looking at Izz. So Izz into half mr square. Okay, and don't read the wrong one. This one outside one is Z comma. Okay, so here you have two components. One is the distance from the Ig. Ig is this one. Ig. This is Ig for your Ig. Half mr square. You have two. You have two objects. One is the big one and small one. So your R value will be different. So then this one, md square. Md square, I already post the answer in the WhatsApp group lah. Okay. So basically, if you read, you look at the photo that I share, this D actually from the G to the O. It's the same for both object, both rigid object. So this one is 0.25 meter. 0.25 meter in D here. Mass you need to find. This is mass of the object. Mass of the ring. This one, the whole ring. Not after you poke a hole there. Is the original ring. So this the first one. M1 is this ring. You need to find mass multiplied by you are given the density, right? So then this density multiplied by the velocity of the 250 mm plate, circular plate, and you find the m here. Okay, same with the second one. Volume. Okay, density multiplied by the volume. So pi r square multiplied by the thickness. So the thickness is 10 mm. So you need to convert to meter, right? Because your density is kilogram over meter cube. So you just need to substitute. I just need to be careful on the mass here. So some of you confused with the mass and G. So I already explained. So the rest of the step is very clear on my slides. So you go home and substitute, you get the answer. Okay, we still applying I equal to IG plus MD square. Still the same. So the second example number 4. So this one already in the slide I already put in the answer. Okay, so this one already updated. So this one also same. If you refer to this one, you're given the G and the O. So this basically, you look at the object, the component actually is a combination of two no, from the is a pendulum, two thin rod. So here the question say thin rod ma. So referring to the rod lo. Okay. This one is rod, so you're referring to the rod lah. The last one. Okay, the last one. So you have two rod. One is like this, one is like this. So how to find the first IG? So IG is the first object is OA object. The G is at the center. So it's a half length of this one. Referring to the diagram also at the center. Because there is a L divided by 2, L divided by 2. So you need to find the first one. The first one, you are using what? Your axis will be here. Your axis will be here. Your axis is here. You are using IZZ for the OA object. Then for the BC you cannot use IZZ. You need to use YY or XX. Sorry, no. Because you need to see your reference axis is here. You need to fix one reference axis, like for example, this one. Okay. This is your reference axis for the whole this one. So OA, this is OA. Your reference axis is like this. This is Z. Then the bottom one is like this. So it's the same Z here. But you need to refer to the diagram where is your reference axis. So this one, because you are traveling to the center of that rod, so you should use IXX or IYY. It's the same. Yeah, it's the same. So you should use half ml square, and if it's IZZ means 0. Okay. Yeah. So this is the trick part lah. Okay. Then MD square. MD square is also by object. By object. So MD, you need to refer to O to the center of the object. So the first one is 1 meter. From here to here, center. And also for the second object, where is the distance? From O to center here. The rod diameter got given or not? 2 2 is given in diagram. Yeah, it's given diagram. So O to the center of the object. There's the D. There's a different concept. Then you have two moment of inertia. Moment inertia 1 OA plus moment inertia BC. Then you get the total moment inertia. That's the trick lah. Okay. So the rest you read, all the answer is there. So the first one is 16 kilogram per meter cube. Second one, okay, the rest you read. Okay, the next one will be also IXX IYY, but you're using this one, this part, you're using IXX IYY because it's going through the center of the object, where you're using this axis or this axis same. So that's why you're using half 1 over square ml square plus md square. Okay. So you substitute lah, you'll get the BC from O, sub O means from O, you'll get 37 point something. Okay. So as long as you get the concept, you don't chase after the numbers. You just when you see rigid body, the first equation is to find the moment of inertia. So how is Ig plus md squared? Then you look in the combination of shape lah. Then need to remember you always need to start from the reference point that is given O. Don't confuse by all the additional information in the diagram. Sometimes we put in extra information just to confuse you. Sometimes you don't need to use information inside the diagram. Okay. The y half, that one is if you are fast, you don't need, you're not referring to this appendix, then you need to use the one that you learn in your static. You need to find the central centroid of your this inverted T shape. There's a table that you need to draw lah. Table, then this shape, all the x multiply m and so on. That one, okay. But for this dynamic, you don't need to build the table, straight away refer to the appendix. Okay, yeah, right. So this is the another part lah. If you want to do the using the y prime, you still get the same answer. You still get the same answer. Okay, so this is what is the difference between A and B? A is the one that referring to O. Second one is the mass center of G of pendulum. So it means that the first one is from this one. The second one is from the center of G here. Means your O change to here. You can change to here, or you can use this equation. Yeah. Part B1, you go home and have a look. So part B1 is basically is all sum of the mass multiplied by the y average y here. This one equal to individual y individual y hat lah. Okay. So it's the same. So like for example, this one, all the mass you can find, density multiplied by the density multiplied by the volume. If not, then you will be given in the question. Now, for example, how do you get one here? How do you get one for OA? Is because for this object is okay. So for this object OA is 1, and then for object BC is 2. Huh? 1.4 something. So this is another method lah. Another method. Because the question asks you to focus on different point on the body. Yeah. So one is on the O, one is on the D. But if you apply the same method, Ig plus md squared, where you put your O at the G point here, then you'll see the same. You still get the same answer. Okay, next we move on. This part I move fast a bit. So we start to go into application of F equal to MA. This part will be in your final exam. Okay, it's still the same like what you learned in the previous particles, but it's just that now we're focusing on the central of mass, the central of mass, the capital G point here. F equal to MA. Previously, you are referring to the object, right? You're not focusing on any point, right? So now you're focusing on the center of gravity there. You imagine how's the center of mass moving? Right? Okay, I'll show you. So this one you should able to understand. So this object is having a weight, and all the weight are focusing on the capital G point, and it's pointing down because of gravity. Right? And this object was rotating anti-clockwise. If you use your right hand rules, is opposite is positive value of your W. The W is positive. Meaning it's coming up from the screen is positive because it's agree with your right hand rules. And all the small F1, F2, F3, F4, they are external force. They are external force. So these are all the vector. So all these vector, you can split into X direction and Y direction. Yeah. So this F equal to MA, you can add all the force together. How? You split F1 to F1X, F1Y, apply the same for F2, F3, F4, and you do all the force in X direction equal to all the MAX according to G. Yeah. So for example, this object, if your direction is X direction, where is your acceleration? Acceleration go down, right? W go down, right? So what is your A to X direction? 0. You are referring to where the capital G central of mass going, the acceleration of your central of mass. Then for the second set, you calculate all the force in Y direction equal to MA, but in Y direction. Yeah, so this will be a bit different. The rest you read. The rest you read. Okay, so all the small force that you see, actually it can be gravitational, it can be electrical, it can be magnetic, it can be physical contact point. Right. For example, this object on the different tied to a different spring or different rope and so on. Right. If it's pointing, then something sharp corner pin to that one and so on. Okay. So if your rigid body, your F equal to ma equation change a little bit, where you will see a sub g at the acceleration. In a particle, you don't need to write sub g because it's either moving to the left, moving up or down, or to the right. Okay. But in this case, you are focusing on central of mass G. Okay. So the rest you read, it's all the same. So you just need to break because you are dealing with vector. Right. So what you need to do is to break all your forces in X and to Y component. And then you are focusing on your acceleration in X and acceleration in Y. Again, if you are seeing this equation, F equal to ma, on the left-hand side, you draw free body diagram. Left-hand side, free body diagram. On the right-hand side is your kinematic diagram or kinetic diagram if you want, right? So usually we just put in your acceleration direction for the on the same, or you can redraw this another diagram for kinematic or kinetic diagram. Okay, it's the same. Okay, I'll show you how to do. So the rest you just read. The rest is also the same, but repeating what you learn. Nothing complex here. Okay, now it's just to show you that we are repeating the same diagram. Mean on the left is F equal to MA. This is a diagram that we expected in your final exam, where you need to draw two diagrams. One is force diagram. One is your kinetic diagram. Sorry, kinematic diagram, because you're seeing MA. The diagram is showing MA and not acceleration. So F diagram on the left, MA diagram on the right. It's the same diagram, but is showing different component. Right? So I can see on the left here is all the force only. Okay, on the force, and then you put in the axis that is given and so on. And then you break the force in X and Y. This is the objective of the left-hand diagram. On the right hand side, it doesn't. On the right side also, you're focusing on the vector of the acceleration. You draw the direction of the acceleration, and you can split into x and y also. Yeah. So this is just for info, just for info, because too many equation, right? So if you take force, multiply by the r, you get moment. Force multiply by the by the perpendicular distance. Yeah. So just recall what is moment. You have axis, and then if you have a force, this is your reference point. This distance is d, and it must be perpendicular to your force. So the moment generated by the force will be Fd. So by this force, you're generating m. So m equal to force cross d, or you can use sorry, if it's a cross, then it's the radius distance cross d. Yeah? This is d cross f. If it's a vector presentation. Okay. Okay, so we move on. This is just a revision of moment. So if you put the force, this force into x and y, so this force in x direction, what is the perpendicular distance? Here, y. And then if you break your force in y direction, what is your perpendicular distance? This one. So you have two moments. One is x direction force and y direction force. Okay, this is on the left hand side. And then right hand side will be your MA point. So MA again, combination of MA give you force. Combination of MA give you force. So once you have a force, you also generate moment. So you take the MAI, you break into X and Y also. Same. So this one, if you break into X and Y, it's also same. So this one is MAX. This is MAY. So to create moment, you must have a force multiplied by the perpendicular distance of the force. So this is a perpendicular distance of the force. So this is the y. So you take this one, cross this y, you get moment. And if you take this one, MAY, it must be perpendicular distance of the force. So this is x. So you take this MAY multiply x, you get a moment. So this is the concept. So this is solving the moment. Sometimes you don't know the acceleration. You can use this approach to balance the both sides, and then something will be missing there. Yeah. So the rest you read, There's nothing. There's nothing there. Okay. So this one you read is a expression or elaboration of your vector mathematic calculation. I won't test you this one. I only test you at the last one. Last one is a long process. This one you read. Go and read. Okay. Okay. This one, this equation is all the elaboration of the vector calculation. The moment at point P here, this is a moment calculation. All the moment at the point P because of the force effect will equal to minus y minus average y of your MA of your force of this one, right? So on the left that I put in yellow color is the top diagram, which is the force effect, and the one in the red color, in the white color is the one diagram below. That is the effect of MA, the total mass of that object. Okay, so here you have the average y negative there. Y negative because go down. It go down from the center of mass there. Go down negative. Okay. And also the same, the next one, the x hat there, the average head here, x here, this one negative because you're moving to the left. Your x is moving to the left, is on the left hand side of the center of mass position there. That's why you get positive, negative. So this positive negative is actually referring to the diagram and not always negative. It sometimes can be positive, sometimes can be negative, depending on the position. If it's on the left, if on the right, you get always positive. If it's going up, it's positive. If you go down negative, go to the left negative. Yeah, this comma here, this diagram, because you're focusing on G, your G is to the left of the reference axis here, so to the left is negative. So why you go down? You go down is negative. Then this one, IP alpha is IP is how you find IP? IP is from the equation that we learned previously. I equal to IG plus MD squared. This is from the previous equation that you learned. This is IG equal to I equal to IG plus MD squared. This one, this IP things, it depends on the body. You need to calculate the moment of inertia for that component or rigid body. So if they have two body consists of two components, you combine the two I, you put it here. So this is equation for moment. It's quite a lengthy process, but this one is usually the x hat and y hat will be given usually. So you don't need to do the one that you learn in static where you find the average x and average y. In dynamic, we will skip that mathematics steps. And we assume we know how to find average x and average y. Yeah? Okay, so here, it's possible to reduce each equation to a simple form if the point P collide with the mass of center on the body, meaning if your P, if your focus point, reference point P move to the G, center of mass, then this one will be 0, this one will be 0. Yeah, so this one, because you have a reference point different from your center of mass, so that's why you have a x hat and y hat there. So if the question just give you an easy question, we will move P directly same as your G. Your equation will arrive at your moment equation. This one 0, this one 0, arrive at IP alpha. IP will be your IG. IG, how to find? Is from the equation I equal to IG plus MD squared. And why you get IG? Because your D is 0. Your D is G and the P is the same on the same spot. So your D is 0. That's why your I equal to IG plus MD squared, your D is 0. That's why you arrive at this equation. Yeah? All right. So the rest you read. Let's read. This one already I did explain this now. Let's explain this now. And quite lengthy, some mathematics. This one is more on the cross products and so on. So I'm not going to that way. At the end, you arrive at one equation. We did this one. Okay. It is your m multiplied by it's still multiplied by the acceleration in x direction and acceleration in y direction. So this will be there are two equations for moment. Okay, one equation is this one, and there's one that previously with the two equation. Then the rest you read for your info. Okay. So this equation MP is for the force diagram. This one MKP means each component moment. Each component moment is a very small component moment. Okay. Okay. The rest you read. Okay. So meaning, so if you read this, when your alpha 0, your moment is 0. Yeah. So it do not rotate. Rotate. This is rectilinear. Rectilinear is actually a moment question. So this one you're quite familiar with all the external force and the forces, W point down, and so on. Right? This is the free body diagram for any that you learn in your static. This one is your acceleration, your mg. So its translation, it moves in the straight line. And again, I want to highlight here, rigid body, you are dealing with MA and not A. The diagram is MA. So MA is a force. Force multiplied by perpendicular distance, you get moment. Yeah. All right. So if you see a rectilinear object, you are using these three equations. All the mg will be 0, the first one. Second one, F equal to MA in x direction. All the y direction, Fy equal to MAY. G1. So if you're having a rectilinear, you are using this one. If you're having a rotational, you need to refer to the equation that we learned previously. You need to find the mg for rotational body, right? So rectilinear is quite simple. Very high chances you are looking at rectilinear motion. Yeah. Okay. So the rest you read. Still the same. M A equal to MKA means it's a two diagram. One is on the left, one is on the right. Okay. Now, what is a little bit different from the previous one? When you need to use moment equation in your free body diagram, you need to give me the distance of your forces that generate moment. Meaning, looking at this diagram. This D is extra from the previous chapter. If you go into chapter 6 or chapter 5.2, this D diagram is previous diagram, you don't need to give me the D. But if the question asks you to give me the moment around the center of mass, I expect to see you are pointing where is your D, perpendicular distance that give me the moment. Yeah. So Okay, the rest is the same. Curlinear, this one, just remember, every time you see curlinear motion, you just break all the force in tangent and normal direction. That is the revision of what you have learned. Okay, although it looks very complex, but still, what I need to remind is break all the force in tangent and normal direction. Normal always pointing in to the curve. Tangent always follow the velocity of the object. Yeah? So this one, you know that if you're pointing this one, meaning that in the question already give you anti-clockwise rotation. Yeah, we straight away go to one tutorial question. Yeah, this one is curlinear. Curlinear means you still recycling the three equation. M equals 0, F equal to MAX, F equal to MA but this one is curlinear. You change the X into normal, Y into tangent. Sorry, X into tangent, Y equal to normal. Yeah. Every time you see a circular one, you change the equation into N and T. If you see a straight line motion, you use X and Y. Yeah, so only three equations for this chapter today. M, find moment. So moment you already expert already. I don't need to explain. Okay, and then F equal to MA, F equal to T. Okay. Yeah, this one you know already. So if you look at this equation, basically it's a moment equation. F equal to moment equal to force multiplied by the perpendicular distance. So you refer to this diagram. So the tangent direction is you are using perpendicular distance is this one, the E here. Because you are referring to B. You're referring to B. There's always a reference point, either O or another parameter, right? So G will be given, and then the reference position will be given. So you always refer to the reference position on the body. Previous one is O, but in this slide here is capital B. Okay, then the H also same, H also from the G to B. Yeah, to create moment. All right. Okay, so this one in other university is one of the final exam question, but for you, I will transfer into your test to test lah. Okay, so by giving you a picture, you should able to give me the free body diagram and the kinematic diagram. So if you seeing this photo, something is pulling the yacht on the support here. So basically, you are seeing this one in your retest lah. Your test one retest, right? So if you pull, then your T is to the right. Your yacht always have a mass always going down. And again, for your test 2 and final exam, if you put your W in somewhere else, I give you wrong answer. If you put your W vectors other place than the G point, I'll give you wrong answer. I will circle thing and then give you a cross there. You won't get full mark for your free body diagram. And some question I'll give you -1. I will minus mark for the location of W. Because you're going into your year 2 next semester. So this should not be repeated. If your careless mistakes here should not be repeated in your year 2 already. Yeah. So I highlight. Start from your test 2 and final exam. Your W always pointing to the central of mass. And do not put in other place. And also, every time you have a contact point, you always automatic have a contact point and normal force there. And always perpendicular to the object. Always pointing to the object to support. Which one? W. W you can put going down here, but it must be at the location passing through G. You must be touching the circle dot of G. Always go down, so you can put down or you can just arrowhead going to the down. Okay, so this is a reminder lah. And then now in the chapter 1, 2, 3, 4, if you learn about particle, you see the contact point only one, only one end here. But when you go into rigid body, every wheels that touch the surface, you have one contact point there. And this one you'll see in the final exam. Just for your info. You will see something like this in your final exam. You will see two wheels touching on the ground. And just give you a highlights, just a give you some tips. Your final exam, I will use aircraft on the runway. Means you have your nose wheel and your back wheels there lah. And in the question, although the back is two wheels, the question already mentioned, assume two wheels as one contact. So in your final, we expect you to draw one contact point for the nose wheel, labeled as A, and the first main landing wheel at the back one. You'll see two wheel in the question, but the question already mentioned assume two wheel as one for the contact point. So you will have two n in the question in the answer. And label properly. One is NA, one is NB. Exactly almost the same as what you see here. I'll be using Airbus 320 model. Okay, so you should know where is your engine thrust pointing to. Where is your aircraft moving? Forward. So thrust will be pointing forward and not to the back. Don't, if this one is the aircraft, your thrust is pointing in front, not to the back. And the thrust must be on the engine. If aircraft, I'll just give you some hints. So your T for the aircraft must be on the engine, and not in front the nose. Must be on this one. And then you transfer your your total mass. I'll give you the central mass of the aircraft, and I will give you the distance from the central mass to the ground. I'll give you the D distance. Okay. So for your answer in final exam, I don't expect you to like a Picasso lah. I don't expect you to draw the very 100% same things. As long as you draw the shape, look like aircraft, can already. Or you really don't know how to draw, you can draw like a road box, I mean all bricks you can change into bricks. I mean bricks shape something like brick shape, but you know it's an aircraft I mean I don't assume a perfect shape like what you see on the question, but I want to see you know how to draw the force or not. Then you know where is the acceleration focusing on or not. This one I expect you to draw something like this. MAG on the G point and not engine. Don't put in the wrong location. Don't go and put MG in the engine location. You go and put in the central of mass G point, the dot point. Okay, so this will be what you see in the final exam. Okay, then the step will be the same. F equal to mg. These three equations. Mg equals 0, F equal to mg x direction, F equal to mg y direction. Basically, because your aircraft is moving on the runway, you only need to solve x direction. But you still need to find Why? Why? Because the question asks you to find N. You need to find the contact force for the front wheel and the main landing gear. Yeah, so you still need the three equation, and so on. Okay. Now, this one I think is in your tutorial, in your assignment. I think this one, right? This one or another one, Okay, so you look at the question and you see the dot G point there. It means it's a chapter 5.2 or chapter 6 question. And you're given all the distance that towards the capital G point. Okay, so means we expect you to find moment already. You see this kind of all this distance, and all this distance 0.3, 0.75, 1.25 is not given in chapter 1, 2, 3, 4. So this one will be in your final exam setting. Okay. Okay, you look at the question, you're given a mass of 2 megagram. You need to change into kilogram. You're given the center of mass there, G. Determine the acceleration if the wheel are always slipping, means they lock the engine and then it's dragged. Where the front wheels are free to rotate. Free to rotate means what? Free rotate means there is no friction force. Cannot say no friction force. But there's no resistance there. There's no resistance there. Okay. So in this question, you're actually focusing on the back wheel that is locked, always slipping. Ignore the mass of the wheel. The coefficient friction is given, means you need to find the friction force over here. Okay. In your final exam, you will be given mu s that you see in statics. Okay. In your final exam, there will be a question. You'll be given mu s, where you need to find whether the object moving or not. And then what if it's moved? Then something happened. So again, just give you an idea. Mu s always will be, static will be always higher than the mu k. This is just a random number, 0.3 just random number. But mu s will be always higher than the mu k. How do you know, how do you find the answer if you're giving the mu s? Same, F equal to ma. This is the sorry. Okay, this one is no. Because mu s, your air always 0. So actually you're finding equilibrium equation. F equal to ma when it's static. F equal, still using F equal to ma, but your A is 0. So actually you're finding the force that make the object moving. Yeah. So go and find question that involve mu s. So this one mu s is not in my slides, but expect it to be seen in your final exam. You need to find the force that make it move, and then at what time it start to move. Okay. So this one, again, two diagram. First one is F diagram or free body diagram. So you only see G and then W equal to mg. And then there are two contact points. There are two contact points, which is NA and B. Okay, and then it do not give you engine, so no thrust there. Don't don't overdo. There's no engine mentioned. There's no additional engine thrust from here. So this basically is a diagram that we're looking at, and friction force is at the back wheel. Front wheel don't have because free to rotate. No resistance. No resistance. Okay, solution A, you use equation of motion. You use moment equation, F equal to ma, F equal to my. These three equation, first solution. Then you substitute based on this diagram. The first equation, you should able to find moment on the center of G here, right? What is the moment? W do not contribute. So you need to identify. We always in here, because we are using right hand rules, our rotation moment always positive anti-clockwise. Because we are using right hand rules. Okay. Now, if you look at this diagram, if you're focusing on G, W don't have because the D is 0. F multiply D. The D for your W is 0, so no moment for W. N will generate moment. So N is anti-clockwise. So you NB multiplied by this distance, or 0.75, we get positive moment. NA clockwise, it gives you negative moment. And there's one more, friction. Friction from here, the distance is here. So it gives you clockwise, so it gives you negative also. Okay. Friction, why pointing this way? Because it slip. And how the wheel moving? Your wheel rotate like this, right? To move front, right? Your wheel moving like this, right? So there's a resistance to the direction. So this is on the wheel. It's a bit different from chapter 1 to 3. Chapter 1 to 3 is the whole body friction. This one is on the component of the wheel. Okay, so this is the example of answer. Okay, the first one is moment, so I don't go deep into there. The next one will be focusing on the force on the x direction. Here, there's only one force in x direction, which is your friction. And the direction should be to the right positive, because we are setting as x and y. So in your question in test 2 and final exam, you'll be given the direction of positive x and positive y. I'll just follow the question. Okay, the same with the y. So should be very direct here. Then you're solving the unknown, solving simultaneous equation. Yeah. So you'll get acceleration of the center of gravity will be 1.959. By looking at your final answer, you should able to detect whether your answer correct or not. If you get negative by a value, it means your car is not moving that direction, not moving this direction, right? Because it's slipping. Yeah, moving forward. Yeah. Okay, so it's moving that way. Moving that way. And your NA is pointing up is correct, and so on. So basically, we are repeating this three formula today for today class. All the moment in G for 0, F equal to MAG X and MAGY. Depend on the axis given. In this case, to the right positive, going up positive. In your assessment, in your assignment, please do the substitution. Please do the substitution in your assignment, the 20% assignment. If you do not show me your steps, you don't get full mark for one question is 10 marks. If you do not show me this one and you straight away give me this one, maybe you less 5 marks there. You are less than 5 marks. Okay, solution 1 is using these three equations. Solution 2 is using free body diagram and kinetic diagram. I know we are overshoot already. So we are using this equation. MA equal to MA. We are focusing on the moment to solve the unknown. Meaning on the left, you only look at the moment of the force equal to the moment moment to the individual moment referring to the center of gravity there, center of mass there. Okay, so there are two sets of solution. One is this three equation. Solution 1 is this three equation. Solution 2, you only look at moment. One side is moment because of MA. Sorry, the diagram actually I flipped already. This side, this one should be different diagram. This one should be this diagram. Yeah. But you still get the same thing lah. So I'll show you the answer. Okay. You still get the same answer. So this one you go home and have a look. For your assessment, you only need to give me one type of solution. Either you give me this one or the previous one. Okay. I've just said your homework. This one, very high chance you will see in your test too. But if see tomorrow, this one you go home and have a look lah. Have a look. Example 7 also have a look. Yeah, tomorrow we continue. Yeah. Okay, you that totally also using this one, yeah.